Hello everyone, this is Bradley. Today this is a tutorial for this procedural folding hand fan, whatever stuff. People requested a lot. In the past, I've done 2 tutorials talking about it, but they are kind of outdated. Either they are using animation nodes or they were done in Blender 3.0, a kind of experimental branch of geometry nodes. And this time we're going to renew the tutorial, but in fact, we are going to change the method completely. In this tutorial, while we are making this folding fan, I also would like to focus more on the problem solving aspect of this issue, because this setup tends to be a little bit tricky and interesting. So let's start. So here we are in Blender. As always, I'm going to use the presets, which you can download for free from the link in the description. First of all, I'm going to talk about mechanics of this folding fan. Actually, the reason I changed the method is because I understand this mechanics a bit more. Basically, the idea of a folding fan is that you have this kind of sticks, which serves a kind of a skeleton structure of this folding fan. And in the resting position, they are basically stacking on the top of each other. And there's either paper or cloth attached to all these kind of skeletons. So I probably will have a different annotation and change the color of it. And basically, we have this kind of paper attached to it. And inside, what in the resting position is kind of being folded. And because of that, when you try to expand that, then the first sticks will rotate out, and the second skeleton rotate a little bit less, and the third skeleton is basically still at the resting position, and this paper will basically expand because it's attached to each of these one. Then we have our papers expanded like this. And you have this kind of a fan structure. Okay. Given this principle, while in the past I was making up this red cloth part first, and then move on to this stick. This time we're going to work with this stick first, and then move on to this cloth part. Okay. The difference sounds to be very minimal. But the change of workflow order is what makes the old tutorial completely unusable. Anyway, here we're going to make a plane to hold the geometry node tree. And the first step is basically just to stack all these kind of sticks. So we start with the curve linear. It's essentially just a curve line node, but instead of 2 points, we're having multiple counts. Okay. And here I'm going to put that on the z-axis. So I have a line erecting. And I have instance on points, duplicating this curve linear, make that onto the y-axis, put that into an instance. So I have all these kind of lines stacking on the top of each other. Next, we need to make all these lines into the sticks. I'm going to use the bevel curve. By default, it's using the round profile. That's why you can see all this kind of tube-like structure. Here, we're going to use the quadrilateral, which is basically a kind of a rectangle-shaped profile. And if we put that into the custom profile, you can see it becomes kind of a square or rectangle-like shape. You can try to change this height. Then you can see how they are stacking on the top of each other. Here, I'm going to change the default scale into 1. And to make this setup a little bit more procedural, I'm going to turn on this step mode, which means from point to point, I'm having a distance of 2. And I basically need to synchronize the relationship between this curve linear step and this quadrilateral. Here, I'm going to use a value precision node to control this entire length, so that you can see the value becomes synchronized, that no matter how I increase the step distance between points, they are always connected. Here, I want to leave out a little bit of space between them. So I'm just going to take a multiply and probably multiply with 0.9 so that there's a little bit of room of breathe so that we do not have the shader artifact as you see here. Okay. Here you can tweak the values a little bit better to make it kind of like a stick, a thin stick. And next we're going to rotate it, but right now we are rotating on the center, which I don't want. So I'm going to untick this centered option so that it's always rotating from one end. I'm going to distinguish the rotation from point to point. So the topmost will rotate the most and the bottom will rotate the least. Here I'm going to use the combine Euler rotation so that I can use the degree instead of radians. And I'm going to put a float range to rotate it on the axis. So you can see there is a difference from the rotation right now to make kind of a stepwise whatever stuff. It's basically using an accumulated field node so that you have this kind of a stepwise rotation. But I'm going to use the stop mode. Otherwise, by increasing the count, then you are having more rotations over time. On the other hand, if I'm changing that to the stop mode, for example, if I'm changing that to negative 180, then no matter how you increase the count, it will stay at 180 degrees in this case. Okay, so this makes it a little bit better. And because this is a negative value, I want to just work with a positive value. So I just put a negative value so that I can have a positive input while having a negative result, just to make my life a little bit easier to scroll on this value. Here, I'm going to use a single value node to control this stop animation. And because this value node by itself does not have a kind of clamp option, so I need to add an additional clamp to make sure it's 0 to 1 range. And I'm going to put a remap 0 to 1 so that I can rotate about 170 degrees for this stop value. So now we have this kind of 170 degree. You can definitely increase the size, but anyway, I probably will just stay with 170. And you can turn off this fan. However, if you go at 0, it does not really go at 0. This is simply because the design of this float range, when this stop value is at 0, then it will use this step size to control the entire result. In this case, we need to distinguish that just to make that 0.001 so that it becomes 100% 0, or at least you do not see the difference because the difference is so tiny. Anyway, so now by controlling this value, we are having this expansion animation of our fan skeleton. It's not a really nice skeleton because usually when you look at the fan, you can decrease it a little bit. Usually when you look at the fan, actually this kind of a skeleton should be elongated a little bit more. In this case, we can take an curve extrapolation. And then you are expanding distance 1 on the start and the stop. Here we do not need to expand on the stop, so I'm just going to have the 1, 1 in this case. You can try to tweak this kind of value either by controlling this stick, or the start factor or the distance. Does not really matter. But just try to eyeball it, then it will be fine. Okay, so now we basically finished the skeleton, but then we need to make up the kind of a class structure for this. The reason we start with these sticks is because we need the skeleton to guide the paper or the cloth part of our fan. And if you only look at the instance we made, it's basically just the curves. And the way we are going to make up the paper part is that we are going to connect these curve lines from point to point to construct a surface. And this kind of concept has been discussed just recently while I was making the blade trail. And I made a tutorial talking about that as well, which takes about 8 nodes. And here I'm just going to use the presets to replace that aid node. That's Loft Curves. And if you put that, everything disappears, and there's a warning saying that input geometry only supports curves. This is because we are having instances. So the way we are going to remove the instances is just to realize that. So we are outputting curves. And now we have a surface being formed. So this is going to be the paper part of our fan. Here we can use the join geometry so that we can visualize both parts of it. And there are definitely several issues. One is that the paper should be above most of the sticks. So we take a set position and elevate just a little bit. For now, this is just to get some quick result. And another issue is that this paper part should not cover the whole range of this stick. So we just need to trim it so that the guide curve becomes shorter. So the surface becomes shorter as well. And it does not cover the whole range of our sticks. And this is customizable. You can just choose a value you want. Does not really matter. Okay. Next, we basically need to solve the issue of these folds. The folds is the most tricky part of this entire setup. Because firstly, we need the geometry in the middle part so that we can elevate all these kind of vertices in middle. Talking about adding vertices of this fan structure, there are several settings I want you to keep in mind. One thing is this guide resampling. It's very straightforward. Sometimes you can just tweak this value and you may probably understand what it does. It's basically resample our guide curves. So maybe our curves start with 2 vertices and you connect the points to point to construct the surface, and you want to have more subdivision, so you just resample and increase more points. And this is what this guide resampling is doing. This is not very important here. I'm just going to keep that too. We need this kind of vertical cuts right now. And this is the cross resampling. This was just implemented recently. And before that, there was another method, which is very easy to think, is just to subdivide the mesh or subdivision surface. Subdivision surface will smooth out this entire mesh, so you can see this kind of edges has been rounded. But the subdivide mesh will not cause this problem. It will make up the vertical cuts that we are looking for, but it also creates a kind of horizontal cuts on our resampled curve. This may cause some problem. Actually, it does cause some problem. So the second method is to use this cross resampling, and I implemented that. The issue is what kind of number are we looking for? At first, I want to mention that when this value is -1, it means it will use the original amount of curves that's presented. But once we change these values, then you can see that you are adding more cuts or adding more curves to connect between these curves during this loft curves operation. Okay. The issue here is what kind of number should we input? And it should be relevant to our sticks number. So in this case, our sticks has kind of a count 11. And I was just brainstorming, maybe we should put a count of 22. And obviously it does not really work because we have kind of a shift. It's not a 100% 50-50 cut. And in this case, I probably will just suggest you to try to play around with this value. And once you play around with 21, you will realize, oh, this is the number we're looking for. We have a perfect middle cut between all these kind of sticks. And this is perfect. So to make this setup a little bit procedural, we can just connect these two values together. So basically the relationship will be, I have an integer for our initial sticks. So I multiply 2 and subtract 1. And then go with this cross resampling so that this setup becomes procedural, that if I increase the value or decrease the value, that I always have a perfect middle cut. And this is great. Next, we need to distinguish these middle cuts from the cuts overlapping with all these kind of sticks. There are multiple ways to do that. And a simple way that I can propose here is basically to compare the geometry with and without the cuts. So I'm going to duplicate these loft curves simply because this cross-resampling method is not exposed. So we need to duplicate to recover the other mesh without cuts. And in this case, we just put this cross-resampling back to -1, so that it's using the default amount of this kind of splines to connect or construct this kind of surface. And you can basically compare this mesh with and without the cuts. Okay, and the way we are going to compare is to use the geometry proximity while we are measuring the distance of these new cuts. And because the geometry without the cuts does not have all these kind of middle vertices, so the distance will be like 1 meter or 2 meter, whatever stuff, does not really matter. Okay, but there must be a distance. The overlapping vertices will, however, be 0 distance because they are overlapping. And you can easily visualize this result. Oh, it doesn't happen. This is because we have an interpolation face, and we can put that onto the points. Then yes, we have all this kind of white distance being shown. So now we basically just select that with greater than, and we can use the set position. So we put that into the selection, and we elevate that. You can see we have all these kind of middle cuts being elevated. There are some issues, but this is kind of float point position. You can easily avoid that with kind of a tiny value, then it will solve the problem right away. Next, we need to think about how to animate that. And I do not want to go back and forth in this node tree. So I'm going to expose this animation factor into our modifier panel. And because we can set these kind of values in the group inputs, so you can see this kind of minimum and maximum on the N panel. So I do not need to have this clamp anymore. And I can just slide this value, and I can open and close this entire fan. And obviously, you do realize we should not have this exaggerated elevation, so we can decrease that. On the other hand, this elevation should change, and basically this kind of paper and cloth should flatten itself as this kind of sticks stretching it. That's why I said we need to use this remap 0 to 1 at multiple places. And essentially this is just a map range node. And only because I need to duplicate this large node a lot, so I put that into a smaller version, because we know our value starts from 0 to 1. So I'm going to pull this 0 to 1 to our combine XYZ. And we can plug it into the offset. And in this case, you just try to deal with all these kind of values. The minimum can be 0 now, because it's not connected to the float range. And you can try to play around with this value. Obviously, it should not elevate, but flatten out. So we can put reverse 0 to 1. So it flattens out. And we can increase the 0 to be a little bit elevated, so that we have an elevation, de-elevation, and so on. But obviously, it should go into the other direction. So this is the next issue that we need to solve. Here, if you think about the resting position of this entire paper, then you can see it actually becomes a plane. And the direction it should basically goes on this x-axis, because between these kind of sticks, it should just have this kind of zigzags, folds. Okay, so This is basically the normal direction of this plane. So that we can just play around with this normal and we scale this vector into the offset. And now if we visualize this effect, it goes into the correct direction. And if you play around these values, you can see it will erect itself as our factor goes, because it's always going at this kind of normal direction. Okay, so this is nice, and we definitely need to fix this magnitude issue. So instead of reverse 0 to 1, I'm just going to put that into a 0, 1, 0 interpolation, so that there's no folds, more folds, and no folds again. Okay, and then next you basically just try to tweak all these kind of values, and definitely there are some issues. Actually, it becomes very obvious as this kind of fold becomes larger, and it basically grows naturally. Okay, so you should interpolate with kind of a brutal force. For example, just grow that very slowly. And you can put this interpolation so that it grows very slow. Actually, we should change the values a little bit as well. Maybe 0.4. Something like that. Something as well. So this is a little bit brutal. I'm not going to spend too much time on that. You basically just need to understand how this is being formed, and try to tweak kind of values until you can accept this interpolation. I think something like that is kind of acceptable to me. So I probably will just stop it here, and we have this kind of fan structure. As we finish the modeling part of this tutorial, basically, we can move on to the material aspect of it. The material aspect is quite straightforward because we have this UV map generated already. If you have watched this Loft Curves tutorial, you will understand how easy to generate this UV map, but it's not very important because it's provided anyway. So we store UV map, and we take a set of material. We need to create a material, and then we plug that into the socket. And then we can go to the shader editor. And I already imported this UV map. So just select that. And if you visualize the render, it's not showing up even in material preview. There's a color, but the UV map is not being shown. This is simply because the texture coordinate has some issue, so it would be better if you use the attribute node and type in this UV map by yourself and use the vector. And then there are still some issues. One issue is that it's being stretched, so you can re-stretch that using this kind of multiplier. The other issue is that we simply do not have enough subdivision. That's why we have all these kind of tilted UV map. So by increasing the subdivision, we can solve this issue. But how? So there's an easy way. You can just subdivide mesh. It will fix. Or you can also change this guide resampling. But just to make sure that you increase both of them. Otherwise, they will be recognized as a kind of new geometry with this proximity operation. It will be kind of very weird. Okay, so we need to we need to synchronize it with this integer value. Then it will also solve the problem. Two ways to do basically the same results. Does not really matter. So now we have this UV map, and it's following this entire fan structure. You can just play around with it. Okay, and this is a procedural setup, so you can increase the count and expose that as well. So you can have a group inputs, and you can put a count into that and use the count to replace these two sockets. You can increase the count, increase the sticks, while everything works still perfectly fine with this setup. Okay. Right now, everything works fine, but I want to talk about a different method for this UV map. It's going to be not procedural, and it will be complicated, but sometimes that might be what you're looking for. Right now, the issue of our UV map is that it starts with a square, so that we have 0 to 1, 0 to 1 on different axes, and we are using a multiply to make that into a kind of rectangle shape. Okay, this is fine, but we are mapping this UV into this fan. This makes that kind of a stretch on the outer ring. And if you look at this UV map, you can see the outer side is kind of being stretched. Okay. And there are multiple ways to think about this issue. Either you work on the texture or you work with the UV map. So here's a different UV map method I want to talk about. That is to projection from view. In this case, we are going to change the workflow a little bit because I'm going to switch yet. So I'm going to use the menu switch so that I can isolate different parts of this geometry while working inside a procedural node tree. So the top will be the sticks, and the bottom will be the fan. Okay, and we are going to expose these settings in the menu so that I have this plane as the stick, and I have a duplicate of objects, but by changing the menu, I have a fan object being created. Okay, and I'm going to shift D to duplicate this node. And actually, I probably will expand into the full size, and then shift D to duplicate that. And I'm going to apply this modifier. So right now, this is the geometry without modifiers. And you probably can see this UV map is this kind of horizontal shape, whatever. And the thing I'm going to do is basically projection from view. So I'm looking at that and I hit U, and there is a projection from view. So you can see I have this fan-shaped UV map being created. And its material will look like more kind of horizontal or rectangle-like. So there will not be the inner ring and outer ring stretch as we see before. And we are going to import this UV map back to our original geometry, because right now this kind of duplicated object has no animation available. So we can name that as a kind of fan duplicate, whatever. And in the node tree, we're going to get UV map object. So there's a preset of get UV map, and I'm just going to select that. So now I transferred this UV map to our original procedural geometry. I can hide that, just don't delete that, and it will go with our animation of this entire stretch. Okay, and you can combine that with the stick. So this is just a way of thinking. It depends on if you need a stretched result or not. But here you also realize an issue: the values are not being synchronized. So here what you can do is just to copy as new driver, and you can just paste that one by one so that you can play around with it. Okay. So this is just a different way of thinking. The downside of this method is simply that as we applied this modifier on our duplicate, here if you just change the count, then this sampling will not match each other. Then this UV map will break, and you have to redo this entire operation. So this is something that you need to think about. Okay, I'm not saying that you must do this operation, but it depends on your needs. The tutorial is basically finished here, but as a procedural setup, I want to remind you that there are many more things that you can potentially do. For example, a fan basically has a kind of rod structure to hold all these kind of plates, and you can definitely do the modeling by hand. But you can also use the initial curve linear, and you can take a bevel curve so that you generate kind of a rod structure. But obviously you need an elongation, so that you just put another curve extrapolation, pick the parameters, something like that. And we can join geometry or join with this menu switch, up to you. I'm going to put that into the join geometry in this case. And you can fill the caps so that there's a cap being filled. And a good part of having this menu switch workflow instead of join geometry is that for different parts of an object, you can have different modifier. The biggest issue here is that for bevel modifier, it's not available in geometry nodes yet. And in this case, you just add bevel modifiers, then you can bevel these kind of rods and bevel our plates as well, whatever. Okay. So this is something that you can always try to tweak, and it'll basically be it. And as a procedural setup, you can tweak all these kind of values. For example, just decrease this length by another magnitude of 10. And you do realize there is a kind of unnecessarily long elevation. And if you close that, you probably will see this being extruded out, whatever. This is simply because the value or the parameters we have in this setup position is kind of bad. So you can just tweak it a little bit more, 0.2 or something like that. Yeah, I think this looks kind of fine. And for many fans, you will realize that the last stick should be above the fan. So you can deal with the UV map by separating X, Y, Z, so that we have this X axis from 0 to 1 on the other axis. If it equals to 1, then it will be selected. So it can be de-elevated. Then you can see the stick is obviously above the fan. So this is something that you can always try to tweak, whatever. This tutorial has been unnecessarily long because this is not a really complicated setup. It does not include many nodes. I hope you can understand the major concepts of it, and instead of just replicating this node tree, I hope you can use these problem-solving skills in the future, whatever. So anyway, I hope you enjoyed this video. I'll probably see you next time. Bye-bye.